Good evening, everyone. My name is Wahid Lutfi. I'm going to share my screen so you can see what I'm going to have for you tonight. In the series of NumPy module that we have discussed so far, we have had a NumPy module 1 training, and then tutorial number 2 and number 3, which is this one. And tonight we're going to discuss number 4. So with number 4, this is what I have for tonight. Let me just go through a slideshow, and we're going to start from the beginning here. So the NumPy module, let me move this one around a little bit. It is going to be tough to just catch it. Let me just see, right, and over here I can move it right. That's a good place right here. I'll put it there. So tutorial number 4 for NumPy Python module, we're going to discuss the NumPy copy, shadow copy method. We call it shadow, versus the NumPy Ravel. The Ravel is like a view kind of things, which is whatever the data dynamically changes, the view also changes. So the shadow copy is a snap and point copy, which I'm going to show you the examples there. And then when at that moment the copy is done, as the shadow is copied at that instance, and the changes is not going to show on the copy. It only shows on the Ravel, and then also it shows on the reference. We're going to also talk about flatten flat, those two for iteration, and then flatten to just make it like a single one-dimensional array flatten. So we're going to just discuss the copy method, the Ravel method, the array method, the arange method. This is not a range, it is a range, like the range function in Python. And this has a start, a stop, and then iteration, where it's a step by going up or a step down, depending on the start and the stop. If it is the start is negative numbers, then a step down, and then if it is positive numbers, a step up. So then arange is just the NumPy version of that one. You can just have one number, or you can have 3 values, a start, a stop, and then a step by. The reshape method is that when you're just trying to reshape an array to a different dimensional, either 2-dimensional, 3-dimensional, or single dimension, you can reshape them. The flat and flat iterable, or objects that within the NumPy, when you create an array, you could say a.flat, and now you're pointing to a flat iteration. Then I'm going to show you the example on that one. Also, the NumPy array reference. Array reference is similar to Ravel. So it is not a shadow copy. It is just kind of a view. Whatever changes are going to be happening on the reference carries on dynamically. Array object attributes, we're going to discuss some of the attributes. And then like in dimension, and I would say show the size, item size, and so on. And then the dir object on the dir command on the np.copy, np.ravel, and so on, all of those ones we can discuss it. So more to come to cover on the later videos. This tutorial number 4 was just the 4th session, and more to come up like tutorial number 5 and so on. We will discuss all of that. And let me just go to the next page, which I'm going to just say thank you for watching. But at the same time, we're saying that please go to YouTube channel at MyWebUniversity.com. This is my YouTube channel. At MyWebUniversity is the handle. So when you go to youtube.com, which is HTTPS at MyWebUniversity, then you will just see our channel. And then you're welcome to watch and like and subscribe. Please do so. And then I'm going to just now demonstrate those examples here. So stay with me, and let me, excuse me, let me just go back to NumPy here. So I already started on the command line, the IPython or Jupyter Lab in this case, by running the Jupyter space dash, I'm sorry, Jupyter space lab. This will just start the Jupyter lab and notebook on the web browser, and then you get this local host at port 8888 by default, and then the name of the Python modules that I named it NumPy underscore tutorial dot underscore 4 for number 4 tutorial dot IPython interactive Python. So you can see this notebook or Jupyter Lab notebook is available. As you work on every cell, you can just run the cell and then undo it. At this time, if I just run this cell, there's nothing here to just, let me move this one again from here. It is on the way, so I'm going to put it somewhere here. That's good enough. Not blocking the word IPython. Okay, so here we are going to just, if I run, there's nothing here to run on the cell. So the first thing I'm going to do is import NumPy as NP. By saying this NumPy module and the alias that we want to import it as NP cell, when you run this one, nothing happens because all it does is just now NP is available as an alias. So if I say dir of NP, you can see all the method and things that are available, whether it's like property or attributes or double underscore method, magic method we call it, or something else like these methods are all right here. So for example, if I want to see the version of NumPy, I could say dot version. And then I think it is the underscore version. Let's see, there's something here with version. Yeah, so underscore most likely right here, double underscore version. That would just give you the version of NumPy. So when you print this one, and instead of the dir, I'm gonna just say print. This will just give me the version of NumPy. So on the next cell, I'm going to just create an array. So I'm gonna call the array A, which is an array, and I'm gonna say NumPy dot, let's just call it with array, and I'm gonna start with a one-dimension array first. So I'm gonna call it array of one dimension, 1, 2, 3, let's say, and then 4, 5, 4, 5. This one is a list of 5 items, 1, 2, 3, 4, inside this array method. So when I do this one and then I say, go ahead, print A, it's gonna give me the array as a 1, 2, 3, 4. If I just wanna know that type of this one, I could say print type of A, then it's gonna say that it's an array object of n dimension there, numpy.n dimension. This is n as multiple dimension, or numpy dimension, number of dimension array. So when you look at that one, if this was one dimension, I could just say n dot a dot n dimension, the number of dimension, it will give me the dimension is 1. And similarly, n dot size would tell me the size of the n dot, sorry, not a dot size, a dot size, because the object does a, so I could get the size is 5 items in it, and that's why. So a dot shape, and then it would say a tuple. This will return a tuple, and it will say that 5 comma, and then there's one dimension, so it's only 5. So you could get all those information also by doing info, np.info and then a. That would just give you all of them in one shot rather than having that many times. So now we did this array here. I'm gonna copy this array here, and I'm just gonna this time create another array, but instead of creating one dimension this time, I'm going to create 2 dimension. By creating 2 dimension, you're going to put these 2 brackets, and then inside the bracket, first one, when you write the bracket, each one of them that you do, you basically say 1, comma 2, comma 3, and then you close that one and then put a comma, and then I have to put another bracket here, and then now and this is 4, comma 5, comma 6. So now notice that when it's 2-dimensional array, you're putting 2 brackets here, which means this one, comma the second one. So it is a 2-dimension of 3 by 3, 3 rows and 3 columns. So if I just say print A, it's gonna give me I'm sorry, 2 rows, 2 rows and 3 columns. That would be just giving you those 1 row, the second row, and 3 columns. So then if I say a dot shape here, the other one was 1 dimension, and then this one is going to return a dot shape is not a function, it is dot shape is an attribute. So you are just saying a dot shape without the parentheses, and that's 2 by 3. You can see 2 rows and 3 columns, and then a dot number of dimension is going to say 2 dimension, and similarly a dot we did the shape, a dot size is going to say the size of it, that is 2 times 3 is 6 items in there, and then a dot item size is going to tell you in bytes how many bytes each item takes, 4 bytes in this case, because it's the type is also int array. So you can see a type A, and then you see that NumPy dot int ND array, and then np.info also gave you all the details here. One more. Okay, so here that is telling you all the details here. So at this time, I'm going to just say we already created this A on the second time as the number of dimension, but instead of creating running all these shapes and everything, I'm going to just say, well, we already did that one. Let's just print A first. Print A. And then on here, when we print A, notice that A is 2 rows and 3 columns. So I'm going to say for A, let's just say A dot C for copy, and we're going to say A dot copy, and then we can just copy that way. So this one, I'm going to say print A underscore C, and then print type of A underscore C, and then that's the copy. And then also I'm going to say print A underscore C dot shape to see what shape it is there. We're going to run all that output. So A type, I just missed one parenthesis here. That one is 2 parentheses. So print AC is just printing this, and then after when we did the copy, we say that what type of AC an array object is NumPy in the array object, and then the shape is 2 by 3 like the other ones. So because it's a shadow copy, it is exactly the copy of that one at the time. There's another one called reference. So let's compare the A dot copy with A underscore reference. I'm going to say A dot, just copy it like that, and then print A underscore reference. And we're going to say print type of A underscore reference, and then print, print one more bracket here, parentheses, one more parentheses I meant, and then also print A underscore R dot shape. So this one, compared to the copy, this is a reference, and the reference is dynamic. What I mean by that one is, if I just make a change here on the copy, So notice that A.123 is there. Then I just make a change here, say A underscore C is equal 5. So is equal 5, A underscore C sub 0. Let's say make sub 0, not the whole entire thing, the entire row, to 5. And just after that one, we just say print of AC underscore C. And notice that we made the first row because we said A sub 0, the entire row, into 5. But if I wanted to just make only the first column, number 1 to 5, I could have just say comma 0, A00, and then that would be just changing the first number to 5, which is right here. And instead of 1, we change it to 5. And if I wanted the 2 to be 5, obviously this would be 0, 1. First row and second column. And then that's there. Similarly, the same thing with 2, if I want to change the 3 to 5. But here, the discussion of the numbers that are being changed. So notice that the AR underscore reference, as we make the change, and the reference is already back to the shape that we were. The copy is modified here, but if I just print A here, notice that A is not changed. The A is still 2 here, and instead of 5. Why? Because A was underscore copy was a shadow copy. So the shadow is just a snap and point. It is not like a reference or a label. And the reference or label is like a view. Whatever you change on that one, it will carry on this one. So now let's do this. Print A underscore R. Actually, we already did that one. Let's just change something here first. We say print A underscore R is the shape. So I'm going to say, let's just change 0, 2 to 10. I'm gonna then print a R. So notice that when we did this one to number 10, that changed it. But at the same time, now I'm going to print A itself. The array A, we are going to see that one, the change carried on. Okay, so the label and then the reference are the same. So now if I just, this was a reference. Now I'm going to just do another array object called A label. Just instead of R for reference, we could have called that one R A underscore reference, but because I have 2 R, the second one, I'm going to call it A underscore label, and I'm going to say A dot label, and then do this. Now, and the same thing that we did here, I'm going to say A underscore R, and I'm going to change the value of 0, 1 to let's say 15. And then we're going to print the same concept here that we did here for one more time for A underscore label. So let's do that, A underscore label. And notice that here, since we are printing it, I want to print this one right before the label change. So we don't have the A get modified twice. So let me just do Control C out of it, Control X actually, and then right here where we are doing the label, I'm going to print that one for this one first, then the label here, I'm going to say A underscore label is 15, and then print A, and then that's it. So let's just run this one. Notice the first numbers were here. The second one, when we change that item number 10, we already modified it, and that already shows up here because of reference. And then when we did the 15, okay, so this 15, somehow it failed. Let me see what is the error. A underscore Ravel 15, print a Ravel, and then say too many indices for one-dimensional array. So that makes sense because Ravel is a flattened file. So a Ravel is not like this. So when you do the automatic Ravel, if I just do this, that would be okay. But let's just make the number 1 is 0. So before I do this one, I'm gonna say print a dot Ravel dot shape. Dot shape should show one-dimensional array here. Let's see what this error now is. A Ravel dot shape. Oh, a Ravel dot number of dimension. A dot number of dimension. The other one also showed up an error. A Ravel and dim. So let me just do a type first. I think I'm not mistyping here. Underscore, that's what the problem is. I mistyped that one. Otherwise, a dot shape should have worked and a dot number of dimensions should have worked. You see that it's a n dimension array, and if I just do and dim, that's a one-dimensional array. So it says that it's actually two-dimension array here, and then the Ravel is returning that two-dimension array. So when we do the changes on the last item, this 15 got changed on the a.Ravel also. So what I'm saying is the Ravel is like a view. It makes the copy and the changes, it carries on dynamically, but the copy itself doesn't do it. Copy is a snap in point or a shadow copy, we call it. Shadow copy is only like a shadow, as it was the last shadow, you're just copying that snap and point. But a Ravel in a reference or not a shadow copy, it's a view. It's a view, meaning that when you're looking at the freeway, as the data changes, the cars are moving, your view is the same kind of view, but the data dynamically changes. You see the dynamic changes. As the data here on the Ravel and reference changes, we're seeing the changes, but on the copy, it is just a shadow copy. So that is explained here. Let me just do another method here that we were discussing on the copy, Ravel, array, arrange, reshape, and flat. So let me just cover two more ways to do arrange and methods. And this time I'm gonna say, let's call it a B, which is any object of array. We don't have to always call it A. This time I'm gonna say NumPy dot a range, and this time I'm gonna say 25. Dot reshape, and I'm gonna reshape it 5 by 5. 5 times 5 is 25. So if I say print B, I'm gonna get an array object of 5 rows and 5 columns, like that. See? So if I just have this one 15, that means I have to have 3 by 5 or 5 by 3, each one of them. So 3 by 5, 3 times 5 is 15, so 3 rows and 5 columns. But if I want 5 rows and 3 columns, I could do it this way. So that's the number there. You cannot just have a number here that is not matching here. So if I have this one 12, I cannot have 5 3 because it's invalid. So in order to do that one, I have to do 4 3. 4 times 3 is 12. So that is working, or 3 times 4 is 12. So that way you can see the 3 times 4 is also 12. You can get it. So let's just do the arrange with 25, and then also with 5 by 5. 5 by 5, that's 25. And then now we have this shape and a range, and now we want to see that b dot shape, see what is the shape of it. You can see that is b dot shape is 5 by 5, and then b dot size is also telling you the size of it, and type of b, you could see an dimension array. And then we could say, if I want to help on it, obviously I could get help, but I could also do info and p.info on b, so I can get all the objects attributes here, all the methods, attributes here, and that is there. It's item size, and the shape is 5 by 5, and the number of dimension is 2-dimensional, or so where is the number of dimension here? I'm gonna just say b dot number of dimension. We can get the dimension. Since it's 5 by 5, it's 2 rows, and 5 rows and 5 columns is 2-dimensional array. And you can see by these 2 brackets starting and 2 bracket ending, and each one of them is 1 row, and then 5 rows. So 5 rows and 5 columns, horizontally, vertically, you could see 5 columns. So we did that, and let's just create another method. We talked about flat. So the flat is another iterable. I'm going to say, if I need help on NumPy, I could also say b dot flat question mark here. So this is another way that you can see on the interactive Python and help on it. So you can see the object name and then flat, and you can see here the examples that are given. So the shape is 6, 2 times 3 rows, and then x dot flat, and then you can iterate over the flat iter. So let's just go with this help we already went through. I'm going to say now a underscore iter is equal, I'm going to say a dot flat. So when you do a dot flat, and then I say print type of a underscore iter, you can see this is an iterable iterator, NumPy flat iter, meaning that if I just say print this one, it's an object. So iterable object, so, or a function, iterator actually. So if I say print a underscore iter, that is not going to help me in this case, because it says, what do you mean by, I need only one. What do you mean by this? This is just at this address that this object is there. Do you want to see the value of those one? I say, yeah, actually, that's what I meant. So in order to do that one, instead of this, because it's a flat iterable, then you could say for item in a underscore iter, and then print the item. Now this time we're going to get the numbers that are there, and instead of those values, we are going to get the actual numbers. So let me just see flat dot a. What? Oh, we're doing on a. Let's do it on b, because b was really big compared to a. That's why I was wondering what happened to this. So we can just say do it on b, and now we're going to get more items, because that numbers is 0 through 24. And you can see if I just wanted to print b here, print b, and just as we see that one, and you can see that's 0 through 24, all of that, okay? And then as I mentioned, the a range function, the a range is having a start and a stop. So I could have just said the stop, start, let's say, start at 2 and then go to 20. So let's say 20, and then iterable 2, And then 2 to 20, how many item is that one? So this is, if I don't reshape it at all, I'm going to do this one first to see what it prints. So it is 1, 2, 3. Okay, so instead of counting that one, I could say print b dot size. That would just give me the size. How many is 9? So I could say dot reshape, and I could say 3 by 3. So that's 9. 3 times 3 is 9. And then when I do this one, notice that 3 rows and 3 columns, and the size is 9. We could do that one also. So the a range method has a start and a stop, and then this way. So if I wanted to do this one to 200, maybe the size is about 30. So maybe it's or 90. 30 times 30. Let's guess it. See if that is a right guess. No. So I'm going to just remove this one. First guess how many items are there in the array. So it's a lot, and it's 99. So what is 99? I'm going to say, let's make it 200, 201, actually 202, one more. 202, and then I'm going to say 3. So we have the 100 there. Actually, 202 would cover the 198 and 200. So that would be just there, not, yeah, 200, and it's there, and it's 100 item. Then I could reshape it by, let's say 50, 2, 50 rows and 2 columns. We could have done that one. Dot reshape 100 was there. Why reshape? Oh, reshape was mistyped. That's why. Sorry. Don't mistype anything. So this is that many rows. I don't want that many rows. I want to say 10 rows and 10 columns. That's 10 by 10 is 100. So I could have done that one. And that would just give you that number of rows and columns. So in this case, if I just do the a dot flat or b dot flat in here, and so I say b is equal b dot flat, and then b underscore I for iterable, then I could say for I in b underscore I, then I say print I. Notice that because this is an iterable object, now instead of printing it this way, I can also print it horizontally. So you could just run it this way and then get all the numbers 2 to 100, 200, all of them there. So the flat method is there. So what you learn from this, just to recap, for each object that we discussed, we basically, let me go through this, and I'm going to go through slide again just to show you what we covered. We covered some of the NumPy methods, and sometimes you have these objects that once you have array objects, a dot something, a dot flat, or a dot flatten, and dot flatten also flatten the NumPy into a single like Ravel kind of things. So flatten is another method that you can just use on the object to flatten the shape. So let's just do that one also, and then we finish this video. So in order to just do this, I'm gonna say b dot flatten, and then I'm going to try this one without the method, and then you can see you're getting a function this. So if I just assign this one to b underscore f for flatten, and then I'm gonna say print, and then b underscore f for flatten, this is going to just give me that NumPy object array. But if I just use the function to do that one, then I'm going to get actual flatten shape for it. So that's all in single user one-dimension array, and instead of two-dimension like in the past here that was there. This one was a two-dimension. You can see this and then this, but on the flatten you're gonna get one dimensional, and you can see that. And if I just say print b underscore f dot shape then I could see that this the shape is 100 comma 2, which is one dimension, and I could say print the b dot a number of dimension, and then it's going to say one dimensional, actually two dimension there originally. That's b dot is there, but b underscore flatten is one dimension because we flatten it. B underscore f dot a number of dimension. That's the difference between one being flat, the other one is not. And then you can see the b underscore f for flatten is one dimension. I hope you liked it. Please make sure you like and subscribe to our channel, make some comments so I can meet your needs. God bless you. Take care. Have fun.